Hello there, math fans. I'm going to prove the quadratic formula here in a second. First, I was thinking about today in class, I sang the quadratic formula, which is this. If you're solving this equation, I always make students repeat after me, and I say, all right, repeat after me. And then we say, negative b. And today in class, I did that, and I waited 10 seconds, and not a single student in a class of 240 repeated after me. Nobody did it. So I did negative b, and then I said plus or minus square root, and then like one student repeated it, and I said, let's restart. And then I did it again, negative b, and like 5 students did it. It's tough. It's tough out there. Negative b plus or minus square root b squared minus 4ac all over 2a. I don't know, I heard that years ago. I also just made a video about how sometimes I really want students to ask why. And so I'm going to finish this with doing a proof, because sometimes if we can't remember a formula or we just have a gimmick to remember it, we can't get it right. Now, in searching online, I realized there's a bunch of other songs. What was it? X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And there's like raps for it. So many people have done this. I saw a video where they said, don't say negative b, say opposite b, because students don't understand if it's a negative be a positive. So it's better to say opposite. I'd never heard that before. X is equal to rho. So X is equal to opposite b plus or minus. Really hard to sing it with a different tune. Okay, I'm going to prove it in a second. If I was a student, I'd be like, why? That would be one of my first questions. Why is this true? It's not some magical thing. It's not wizardry. There's some reason it's true, and it's probably not that hard to show. So I'll do that in just a second. But I do want to talk about solving. When I teach this, I go, 0 is lovely, because if you have a 0 over here and you can factor, and you have two numbers that multiply together to give you 0, one of them must be 0. So if you've never seen this before, you try to do this. Now, my daughter's learned all sorts of factoring methods, but it's really, can you think of two numbers that multiply together to give you negative 10 and add together to give you 7? Is that possible? I think it's not possible. I think I meant to have something else there. I could restart the video, but I'm not going to. Let's do an example. So how about we do negative 2 times 5? Here's how you cheat. But I've been trying to show I'm not smart. Okay, so if I add those two factors together, I'm going to get a 3. Okay, so this is how you make a problem on the fly. And you always should double check. So you should monkey face it back out. This time this is x squared. This time this is negative 10. The nose is negative 2x. The mouth is 5x. Okay, that works. So if I can easily factor, that's what I get. And then I have two possibilities. I tell students I'm going to hide two things behind my back and tell you that their product is 0. And they have to tell me what the numbers are. And there's two possibilities. The correct word to put here is or. Sometimes students say and, which is not quite correct. I don't take off for that. But x minus 2 has to be 0, or x plus 5 have to be 0. So you either get negative 5 or x equals 2. I've seen students try to use this logic when there's not a 0 there, but that doesn't work. It's got to be a 0. Okay, that's the factoring method. So what happens if you can't factor or the numbers aren't nice? Then there's a different technique. There's a general technique, actually, that never requires factoring. It's this technique called completing the square. And the reason that it's troublesome to solve this is because you have an x squared and an x. So the technique is to make it so that doesn't happen. That's all the quadratic formula is doing, is completing the square. Now, completing the square is one of these techniques that my students complain about a lot as being hard. So here's my quick explanation of completing the square. And it's this idea. If you had a perfect square, I tell students you can always just run an experiment. That's an overarching theme in everything I do whenever you're confused. There's a perfect square. Okay, so if it's a perfect square, that means it's x plus 7 times x plus 7. And then you can monkey face it out. If you haven't seen, here's the eyebrows of the monkey face. Here's the nose. Here's the mouth. This same class, I've shown them the monkey face like 5 or 6 times and not a single laugh. And I always say, you guys are absolutely right. It's not funny, but I'm going to keep doing it until you laugh. Okay, so then in the middle, we get this 14x. That's a perfect square. And I tell students, if you ever forget what a perfect square looks like, the question is, what does this number need to be? Let's erase it. And then it's easy to remember. Half the middle, squared. That's the technique. Now, there's details I could talk about. There's a more general discussion, but I always just run that experiment. So I go, well, if this were a perfect square, what number would I need here? Well, it would be half the middle, which is 6, squared, which is 36. So let's do that. So what do I mean put a 36 in there? There is not a 36 in there. There's a negative 10. Here's what you do. You put a 36 there. Now, you can either add 36 to both sides, or you can subtract a 36, which is what most people do. And it's just a way to change the look. But it changes the look in a very useful way. I'm just going to move this over a little bit. It changes the look because now this is a perfect square. That's why it's called completing the square. And it's going to be x plus 6 squared. If you don't know where the 6 is coming from, it's factoring. But that number is always going to be half the middle. Half that 14. And then the question is, what's left? Minus 46. And at this moment, we have something that can be easily solved in 3 steps. Can you solve that in 3 steps? Well, you're going to get x plus 6. So we're going to give up the 0 for a moment. Then we're going to say there's 2 possibilities. X plus 6 could be negative the square root of 46, or x plus 6 could be positive the square root of 46, and then we're going to subtract 6. So it's negative 6 minus the square root of 46, and negative 6 plus the square root of 46. And you should recognize that that looks an awful lot like the quadratic formula. It has the negative b, it has the plus or minus. Okay. So at some point somebody was like, well, students in algebra are encountering this a lot. The students we have in our classes can't complete the square because they're scared of it. So we'll just complete the square for them once, and we'll call it the quadratic formula. We'll make up a goofy song, and then students can use that for the rest of their lives. So let's actually do it. Let's ask the why. So what I like to do is divide everything by a first. Again, there's another way to complete the square, but I would like to make it look just like what we did. And you can see how I do an example first, and then I use that example to help me think through the process. So I just divided everything by a. All right. And now I'm in a situation that's just like this. Now I'm going to complete the square. How did we complete the square? We did half the middle. Now in this case, this is the middle. Half the middle squared. So half the middle is b divided by 2a. Some of you might recognize that as part of a formula for something else, negative b over 2a, but that's a different story. Okay, so I'm going to square this. Okay, this gets a little hairy algebra-wise, but if we can make it through, we'll get the quadratic formula. And you can do it. You don't have to be a brainiac to do it. So we're going to square this, and we're going to insert it right here, just like we did with the 36. So let's write that step. So we're going to have x squared. And I haven't done this in years. I'm doing it on the fly. Let's see if we can do it. This is going to be b squared over 4a squared. I don't know how I want to write it yet because I haven't thought carefully about this. Why don't you prepare for the videos? Good question. Too many things to say. All right, and now we're going to finish the solving. Because we did this, this is a perfect square, and this is the number that's going to be in there. So it's going to be x plus b over 2a squared. That's lovely. And then just like we did here, I'm going to move the 46 to the other side. So I'm going to move this to the other side. What's that going to look like? So if I move it to the other side, I'm going to get the following. I'm just kind of looking at it. So I'm going to have b squared over 4a squared minus c over a. So it's minus because I subtracted, it's this. And you can start to see the skeleton of the formula appearing. Now at some point, somebody was like, if I take the square root, it's really messy. Is there anything I can do to make that look a little nicer? And there is. I can get a common denominator, but that would require I multiply top and bottom by 4 and top and bottom by a. And that's going to give me x plus b over 2a squared is equal to b squared over, and now I can put this 4a squared. And then I have these three numbers, c, 4, and a. So it's negative, and people like to write 4ac. And now you see the formula forming. The next thing we're going to do is say there's two possibilities. X plus b over 2a could be minus the square root of this. And here's a key observation just to save me some writing. When you take the square root of a fraction like this, you can take the square root of the top and bottom. But the square root of the bottom is just 2a. So you get these two possibilities, either plus or the minus of the square root of b squared minus 4ac all over 2a. And then you move this to the other side, so it's negative b over 2a plus or minus the square root of b squared minus 4ac 2a. And then somebody said, well, that's not as fun of a song. Negative b over 2a plus or minus the square root of b squared minus 4ac also over 2a. So someone said, well, we can just write it with a common denominator. Plus or minus square root b squared minus 4ac all over 2a. So there you go. It's completing the square. I know that was a lot of algebra, but I want students to ask why. Now, the other thing I notice is that there's a collection of students in my classes that can't do that. They can't actually plug that into a calculator. Now, that's a different problem, but I'll finish this with what I tell those students. So imagine you're doing x squared. I'm trying to get our original example. Plus 12 minus 10. Plus 12x minus 10 equals 0. I think the problem is, there's this overarching problem I see, where students try to plug an entire expression into their calculator. And that doesn't make sense to me. It's also not practical, and it's also not faster. So if I was doing it, I would do it in pieces. And the pieces are compute everything under the radical, compute the denominator, and then it's fairly easy to compute. But it's nice if you can compute and write down those pieces, you're much less prone to error. So the thing I would be computing here, and I might even want to do it in the margins, but it's going to be b squared, so it's 12. And I would just write that 144 minus 4ac. So it's 4 times 1 times negative 10 all over 2a. And I wouldn't even write 2a. I would, well, in this case, a is 1, so I guess I cheated a little bit. But I would compute that. And then I would write down x is equal to negative 12 plus or minus. And so I think part of it is this unwillingness to write things down. They're saying, what are you doing writing things down, Dr. Lovelace, you old, gross man? But there we go. We could simplify further, but I hope you get the point. So I think I will continue to sing it because my students like it. They like to hear me make a fool of myself. But I do want my students to ask why. The quadratic formula is not wizardry. It comes from somewhere. It basically just comes from completing the square. And then someone said, oh, I got the answer. So please keep asking why. I want people to post questions to me. Why does this work? Don't just, when you see why, you learn a lot more, and you remove this idea that math is some sort of bag of tricks where you have to be smart. All right. I hope that's interesting.